Now we'll solve a question. dp upon dv at constant t, dv upon dt at constant p, and dp upon dt at constant v is equals to what? Four options are given. The correct option is none of these, because if we put all the three values, we will get minus nRT upon v square into nr upon p into nr upon v, which will be equals to minus n square r square upon v square. Now the van der Waals equation, if we solve for p is equals to nRT upon v minus nb minus n square a upon v square. If we differentiate p with respect to t at constant v, we get this equation. If we differentiate p with respect to v at constant t, we get this equation. Now if we have to find out dv upon dt at constant p, so we'll differentiate both sides with respect to t at constant p. Then after solving, first we will differentiate this term, and this will remain as it is. Then we will differentiate second term, and first term will remain as it is. So we have written as, and this will become on r because t will be differentiated. Now b is a constant, it will be cancelled out. A will be p is a constant because at constant p a will be common. Then the equation becomes this. Now this will remain as it is. Now this we will multiply and divide by dv. Then this will become a v minus b dv upon dt at constant p dv whole minus 2 upon dv at constant p. Now after solving this, we get dv upon dt at constant p is equals to r upon p plus a upon v square minus 2a v minus v upon v cube. Now coefficients of thermodynamics. Alpha is equals to 1 by v dv upon dt at constant p, isobaric thermal rays expansion coefficient, also called expansion coefficient. Beta is equals to minus v 1 upon v dv upon dp at constant t. It is isothermal pressure rays compression coefficient. Now alpha is equals to change in relative volume with respect to temperature at constant pressure. Now gamma is equals to 1 by p dp upon dt at constant v. For ideal gas, alpha is equals to 1 by t, beta is equals to 1 by p, and gamma is equals to 1 by t. So if the four options are given, what is the correct relationship? Alpha is equals to gamma because both are equals to 1 by t. Now among the four options, what is the correct relation? Alpha is equals to beta gamma. P is correct relation because beta is equals to 1 by p will be cancelled out with p. Gamma is equals to 1 by t and alpha is equals to 1 by t. Now of these, the correct relation is alpha square tv upon beta is equals to r. Now the first thermodynamic equation of state is du is equals to du upon dv at constant t dv plus du upon dt at constant v dt. Second equation is dh is equals to dh upon dp at constant t dp is plus dh upon dt at constant p dt. The first equation is change in internal energy with respect to volume at constant temperature is internal pressure. Second equation is change in enthalpy with respect to pressure at constant temperature. Now the question is du upon dv at constant t is what? At 300 Kelvin. Dimension is pressure. ds upon dv at constant t is equals to dp upon dt at constant v. It is the hint, it is the Maxwell relationship. Now the answer is du is equals to tds minus pdv, we know. Now with differentiating with respect to v at constant t both sides, so we get this. Then putting the value of ds upon dv at constant t is equals to dp upon dt at constant v according to Maxwell relation. Then solving for dp upon dt at constant v is equals to nr upon v, putting t nr upon v, which is also equals to p, so p minus p is 0. Now next question is dH upon dP at constant T, what is the dimension? So dH upon dP at constant T is equals to since we know dH is equals to TdS plus V dP, so differentiating both sides with respect to dP at constant T, then it is a Maxwell relation that ds upon dP at constant T is equals to dV upon dt at constant P. So it will now dV upon dt will be equals to nR upon P. So minus nRT upon P is also equals to nRT upon P is equals to V. So V minus V will be cancelled out. So dimension is volume, since both side volume, so volume is the dimension. If U is a function of V and T, then pi T is equals to du upon dV at constant T. And what is du upon dt at constant P? So it will be Cv plus pi V alpha. How? Du is equals to du is a function of V and T, so du upon dV at constant T dV plus du upon dt at constant V dt. So du upon if we have to find out du upon dt at constant P, so both side differentiate with respect to dt at constant P, this equation. Then it will become, since pi is equals to du upon dV at constant P, so put the value of put the pi, and then this will remain same, and this will cancel out, and this will become Cv. Now divide and multiply by V, so we'll get pi V alpha and Cv plus pi V alpha.